class, we are going to study ICSE Class 10 Maths Chapter 5 Quadratic Equations. We'll understand the concepts of quadratic equations with examples and solve more questions from exercise 5A. Are you all ready? Yes, let's study together. Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. Before dealing with quadratic equation, first let's see what equations are. When we studied the chapter linear inequation, we started with equations. In case of equation, we'll be having an LHS and an RHS with an equal to sign between them. That is, LHS and RHS are equal. When you take a linear equation, linear equations are of the form AX plus B is equal to C, where A, B, C are real numbers. And the second condition is A not equal to 0. For example, 4x plus 1 is equal to 8. This is a linear equation. This is of the form AX plus B is equal to C. Here A, B, C, 4, 1 and 8 are real numbers. The value of A is not equal to 0. Now I'll take another example. 3x square plus 4x plus 1 is equal to 20 and 12x cube plus 3x square plus 4x plus 1 is equal to 56. Okay, I've taken 3 examples. Are they equations? Yes, they are equations because left hand side and right hand side are equal. They are equation. Now, what is the difference between them? Here in the first expression, the highest power of x is 1. Okay. In the second, the highest power of x is 2. And in the third, the highest power of x is 3. If the highest power of x is called degree. Okay. Highest power of x is called degree. In the first, the degree is 1. If the degree is equal to 1, then we call them linear equations. Okay. Linear equations. When the highest power is 2, we call them quadratic equations. Quadratic equations. And when the highest power is 3, we call them cubic equation. We are not going to study about cubic equation, but the basic idea we need is about quadratic equations. So, we know quadratic equations are equations where the highest power of the unknown or the highest power of x is 2. Okay, let's see what the standard form of a quadratic equation is. What are quadratic equations? We know quadratic equations are equations of degree, the highest power of x, 2. Okay, here equations of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a not equal to 0. This is the standard form of quadratic equations. Equations of the form ax square plus bx plus c is equal to 0. Here another condition is a, b, c are real numbers. The first condition means the highest power of x should be 2. That is, degree should be 2. The second condition is a, b and c should be real numbers. And the third condition is a not equal to 0. What happens if a is equal to 0? We'll be getting bx plus c. That is again a linear equation. It is not a quadratic equation. When a is equal to 0, we get 0 into x square. That is, the x square containing term vanishes. Okay. Now, for example, if I put a is equal to 1, b is equal to 2, c is equal to 3. I'll be getting 1x square plus 2x plus 3 is equal to 0. This is a quadratic equation. Here, a is the coefficient of x square, b is the coefficient of x and c is the constant. Okay. A is the coefficient of x square, b is the coefficient of x and c is the constant. Now, a should never be equal to 0. Just remember this thing. If I take a is equal to 1, b is equal to 0 and c is equal to 2. What is the quadratic equation? Equation will be 1x square plus 2 is equal to 0 because 0 into x becomes 0. Is this a quadratic equation? Here a is not equal to 0. The first condition, highest degree of x should be 2. That is satisfied. Second condition, a, b, c should be real number. b is equal to 0. 0 is a real number. A is 1 and c is 2. That is also satisfied. Now the third condition, a not equal to 0. That is also satisfied. Here a is equal to 1. This form is also acceptable. Yes. Now what happens if c is equal to 0? A is equal to 1, b is equal to 2 and c is equal to 0. What is the quadratic equation then? 1x square plus 2x is equal to 0. Is this a quadratic equation? Here, first condition, the highest power of x is 2. That is satisfied. Second condition, a, b, c are real numbers. A is equal to 1, that is a real number. B is equal to 2 is a real number. C is equal to 0. 0 is a real number. That is also satisfied. And the third condition, a not equal to 0. A is equal to 1. A not equal to 0 is also satisfied. This is also an acceptable form. Okay. Now, where does this quadratic equations help us in real life? Let's see. Here, I am taking a square. Let us say the side of this square is x. I am pulling this from all sides and increasing 1 centimeter each from all sides. Okay. Then I will get a bigger square. This is of side x plus 1. I know the area of this bigger square is 25. Area of bigger square is 25 centimeter square. Okay, I need to find what the side x of this square and the side x plus 1 of this square is. Okay, what is area of a square? Area of a square is side into side. In this case, the area will be x square. And in this case, the area will be equal to x plus 1 whole square. Okay. Here, I know the area of this big square is 25 centimeter square, which means x plus 1 whole square is equal to 25. Or a plus b whole square is equal to a square plus 2ab plus b square. That is x square plus 2x plus 1 is equal to 25. Okay, taking this 25 to the opposite side, x square plus 2x, 1 minus 25 is minus 24. Minus 24 is equal to 0. This is a quadratic equation. Yes, if I need to find the value of x, I just need to solve this quadratic equation. If I know how to solve a quadratic equation, I can find the value of x. If I get x, then this is the side of the small square. If I get x, I can even get the side of the bigger square. Just I need to add 1 with x. Clear? So, I will be teaching you how to solve quadratic equations later. Okay. Now, let us take another example where quadratic equation is going to help us. We are discussing the case of a boy who is going to appear for ICSE board exam this year. Okay. Depending on the number of A grades he gets, his father, mother and brother promise to give him chocolates. Let's see. Let us name the boy A. Okay. If A gets 1 A grade, then father will be giving him square the number of A grades. Number of chocolates equal to square the number of A grades. Then father is giving him 1 chocolate because he got 1 A grade. Father will give him 1 square, which is 1. Mother will be giving him 2 times the number of A grades he gets. Number of chocolates is equal to 2 times the number of A grades he gets. Then here it is 2. And whatever happens, brother will give him only 1 chocolate. Okay. Now, if he gets 2 A grades, father will be giving in 2 square number of chocolates. 2 square is 4. Mother will be giving him 2 into 2 number of chocolates, that is 4. Okay. 2 times the number of A grades. Number of chocolates is equal to 2 times the number of A grade he gets. And brother will give him only 1 chocolate. If he gets 3 A grades, then father will be giving him 3 square, 9 chocolates. Mother will give him 2 into 3, 6 chocolates. And brother will give him 1 chocolates. So, in the first case, what is the total number of chocolates? 1 plus 2 plus 1, that is 4. In the second case, if he gets 2 A grades, 4 plus 1, that is 9. And if he gets 3 A grades, 9 plus 6 plus 1, that is equal to 16. If we take the number of A grades he gets as X, okay, if he gets X A grades, then what is the number of chocolate that father gives? We can represent it as X square. Number of chocolate mother gives is 2X. And brother will give him only 1 chocolate. Then what is the total number of chocolate? Total number of chocolates will be equal to X square plus 2X plus 1. This is a quadratic form, right? Okay. Total number of chocolates is equal to X square plus 2X plus 1. Let us see. If we take the first case, we know the total number of chocolates is 4. What is X here? Here X is equal to 1. 1 square plus 2 into 1, 2 plus 1. That is 1 square 1 plus 2, 3, 3 plus 1, 4. Here LHS and RHS we are getting 4. Yes. Now we don't know what is the number of chocolates he gets. Okay. If you know the value of X, you can find the total number of chocolates. And if you know the total number of chocolates, you can solve for the value of X and get what? The total number of A grade he gets. Here, again in this example, quadratic equation is going to help us. If the total number of chocolates is not, you can find what the number of A grades are. Okay. If you know to solve the quadratic equation, you can easily find the number of A grade he gets. Clear? Now we know what quadratic equations are. We'll discuss 2 different types of quadratic equation. Pure and adfected quadratic equation. What is the standard form of a quadratic equation? Quadratic equation is of the form ax square plus bx plus c is equal to 0. Here, the 3 conditions are: first, the highest degree of x should be 2. Second, a, b and c are real numbers. Third, a not equal to 0. For example, 4x square plus 3x plus 1 is equal to 0 is a quadratic equation. Now, we'll take another example. 4x square plus 3x is equal to 0. Is this a quadratic equation? Check the condition. First condition, highest degree of x is 2. Satisfied? Second condition, a, b, c are real numbers. Here we don't have a c. What does that mean? C is equal to 0. 0 is a real number. A is equal to 4 is a real number. B is equal to 3 is also a real number. So, second condition is also satisfied. Third condition, a not equal to 0. Here a is equal to 4. That is also satisfied. Now, this is of the form ax square plus bx is equal to 0. This form of a quadratic equation which contains the x square containing term and x containing term is called adfected quadratic equation. Adfected quadratic equation. Now, I'll take another example. 4x square plus 3 is equal to 0. In this example, we have the x square containing term and the constant. Here, the middle term or the bx is absent. Okay, this form is represented as ax square plus c is equal to 0. Okay, this form of quadratic equation is called pure quadratic equation. Got it? Adfected quadratic equation is the form ax square plus bx is equal to 0 and pure quadratic equation is of the form ax square plus c is equal to 0. That is adfected quadratic equation. If a quadratic equation contains only 2 terms, one square term and one first power term of the unknown, it is called adfected quadratic equation. This is the square term and this is the first power term of the unknown. Unknown here is a variable, that is x. Okay. Now, pure quadratic equation. If a quadratic equation contains only the square of the unknown, this is the square of the unknown and c is a constant, it is called pure quadratic equation. Understood? So, these 3 forms are acceptable. That is a normal form. Ax square plus bx plus c is equal to 0. This is a standard form. Then, ax square plus bx is equal to 0. That is adfected quadratic equation, and ax square plus c is equal to 0. Pure quadratic equations are acceptable. Remember, a should never be equal to 0. B can be 0, c can be 0. Okay, now you all have a clear idea about quadratic equation. We know the standard form of quadratic equation. Let's do an example. Here the question is 3x minus 2 into 2x minus 3 equal to 2x plus 5 into 2x minus 1 a quadratic equation. We need to find if this is a quadratic equation. Let's start. Given 3x minus 2 into 2x minus 3 is equal to 2x plus 5 into 2x minus 1. Okay. Now, solve each part separately. Here we have to multiply 3x into 2x minus 3, which is a distributive property. Minus 2 into 2x minus 3 is equal to 2x into 2x minus 1 plus 5 into 2x minus 1. Okay. Now multiplying, removing the brackets. 3x into 2x is 6x square. X into x is x square. 3x into minus 3 minus 9x minus 2 into 2x 4x. 4x minus 2 into minus 3 plus 6 is equal to 2x into 2x 4x square, 2x into minus 1 minus 2x plus 5 into 2x 10x minus 5 into minus 1 minus 5. 6x square minus 9x minus 4x, which is minus 13x plus 6 is equal to 4x square minus 2x plus 10x. You will be getting plus 8x minus 5. Now bringing all the terms to the left hand side. 6x square, 4x square. 6x square, taking this, it becomes minus 4x square. Minus 13x plus 8x becomes minus 8x. Plus 6 minus 5 becomes plus 5. Plus 5 is equal to, what about RHS? When you have removed everything, in the RHS you will be getting 0. 0. 6x square minus 4x square, that is 2x square minus 13x minus 8x, which is minus 21x. Plus 6 plus 5 plus 11 is equal to 0. Here we got a quadratic equation. Yes. Why? Because this is in the standard form. The standard form is ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0. Now compare this equation. We have a is equal to 2 into x square, b is equal to minus 21 and c is equal to 11. The given expression we could express in the form of the standard form of the quadratic equation, which means this is a quadratic equation. This is a quadratic equation. Clear? Just solve the given expression. Solving, if you get the standard form with some real number values for a, b and c, then it is a quadratic equation. Okay, let's move on to the next example. Example 2. This is a similar question. Is 3x into 2x minus 5 plus 6 is equal to 2x into 3x plus 5 minus 6 a quadratic equation? The same procedures. Take the expression, that is 3x into 2x minus 5 plus 6 is equal to 2x into 3x plus 5 minus 6. Removing the brackets. 3x into 2x is 6x square minus 3x and 5. 3x into minus 5 minus 15x. We have a plus 6 here is equal to 2x into 3x, that is 6x square plus 2x into 5, that is 10x minus 6. 6x square, shifting all the terms on the RHS to LHS, minus 6x square minus 15x minus 10x plus 6 is equal to 0. Okay? 6x square minus 6x square gets cancelled. Minus 15x minus 10x, that is minus 25x. Then plus 12 is equal to 0. This is our final expression. Is this a quadratic equation? What do you think? Quadratic equation should be in a form ax square plus bx plus c is equal to 0. Or ax square plus bx is equal to 0. Or ax square plus c is equal to 0. Here we don't have a term containing x square, which means the given expression is not a quadratic equation. Okay? The given expression is not a quadratic equation. Not a quadratic equation. Clear? So, in the first example, we got a quadratic equation because on solving the expression, we could express it in the form ax square plus bx plus c. At least if we could get ax square plus bx is equal to 0 or ax square plus c is equal to 0, then also it is a quadratic equation. But here we don't have a term containing x square, which means the given example is not a quadratic equation. Let's move on to the next problem. Let's move on to example 3. For a quadratic equation, 3x square plus 5x minus 2 is equal to 0. Show that x is equal to 1 by 3 is a solution, and the second part, x is equal to 3 is not a solution. To solve this, we just need to substitute the given values of x in the quadratic equation. Okay? If on substituting these values, we are getting LHS and RHS equal, then it will be satisfying the quadratic equation. This will be a solution of the quadratic equation. If not, it is not a solution of quadratic equation. Let's try. The first one, x is equal to 1 by 3. Okay, the given quadratic equation is 3x square plus 5x minus 2 is equal to 0. Take the LHS. On the left hand side, we have 3x square plus 5x minus 2. Now substitute the value of x. Here, the value of x is 1 by 3. On substituting 1 by 3, we get 3 into 1 by 3 whole square plus 5 into 1 by 3 minus 2. Okay, which is equal to 3 into 1 by 3 whole square. 1 by 3 whole square is 1 by 9. 3 into 1 by 9 plus 5 into 1 by 3 is 5 by 3 minus 2, which is equal to 3 and 9. 3 3s are 9, which means you will be getting 1 by 3 plus 5 by 3 minus 2 equal to, taking the LCM. Here the denominator is 1. LCM will be getting 3. Numerator 1 plus 5 minus 1 into 3 is 3. 3 into 2, 6 minus 6, which is equal to 1 plus 5, 6. 6 minus 6, 0. What is 0 by 3? If you divide any number with 0, you will be getting 0. So here LHS is equal to 0. What about RHS? In the right hand side, we already have 0, which means LHS is equal to RHS. LHS is equal to RHS. That is, x is equal to 1 by 3 is a solution. X is equal to 1 by 3 is a solution. Now let's take the second part. In the second part, x is equal to 3, we have to show is not a solution. Take the given quadratic equation, 3x square plus 5x minus 2 is equal to 0. What is the LHS? Same steps. LHS we have 3x square plus 5x minus 2. We have to substitute the value of x, that is given x is equal to 3. 3 into 3 square plus 5 into 3 minus 2. 3 into 3 square. 3 square is 9. 9 into 3, 27. 27 plus 5 into 3, 15 minus 2. 27 plus 15 is 42. 42 minus 2, 40. You will be getting LHS is equal to 40. What about RHS? RHS is 0, which means LHS not equal to RHS. That is, the given value x is equal to 3 is not satisfying the quadratic equation. That is, it is not a solution of the given quadratic equation. Not a solution. Clear? In both the cases, we have done the same steps. Take the RHS, substitute the value of given x and find if LHS and RHS are equal. If LHS is equal to RHS, then it is a solution. If LHS not equal to RHS, then it is not a solution. Clear? Let's move on to the next question. Example 4. If x is equal to 1 by 2 is a solution of the equation 2x square plus px minus 6 is equal to 0, find the value of p. It is given that x is equal to 1 by 2 is a solution, which means if you substitute x is equal to 1 by 2 in the given quadratic equation, it will be equal to 0. That is, LHS will be equal to RHS. That is 0. But we don't know the value of p. Substituting values of x, you can find the value of p, because it is given that the given value x is equal to 1 by 2 is a solution of the equation. First, we have to convert this mixed fraction x is equal to 1 by 2 into an improper fraction. X is equal to 1 by 2, which is equal to 1 into 2, 2, 2 plus 1, 3. That is 3 by 2. Okay. Now take the equation, that is 2x square plus px minus 6 is equal to 0. Substitute the value of x, because given x is a solution of the equation. 2 into 3 by 2 square plus p into 3 by 2 minus 6 is equal to 0. 2 into, what is 3 by 2 whole square? 9 by 4 plus 3 by 2p minus 6 is equal to 0. Solving this quadratic equation is very easy for you now. I know. Cancelling, you will be getting 9 by 2 plus 3 by 2p minus 6 is equal to 0. 3 by 2p is equal to, keeping this variable containing term in the LHS and taking all other terms to the RHS. Minus 6 becomes plus 6, 9 by 2 minus 9 by 2. Okay, 3 by 2p is equal to 6 minus 9 by 2, which means 3 by 2p is equal to, taking LCM, here the denominator is 1, 6 by 1. You will be getting 6 into 2, 12 minus 9 into 1, 9. 3 by 2p is equal to 12 minus 9 is 3 by 2. Okay. P is equal to 3 by 2 into taking the reciprocal and multiplying on the opposite side. 3 by 2. Reciprocal of 3 by 2 is 2 by 3. 2 by 3. Cancelling 3, cancelling 2. Then the value of P is equal to 1. We determine the value of P. Very easy question, right? Here in the given question, it is given the solution. That is x is equal to 1, 1 by 2 is the solution. From which we found the improper fraction of x and substituted the value in the given equation, found the value of P. Here P is equal to 1. Okay, next example question. If 2 by 3 and minus 1 by 2 are the solutions of a quadratic equation, 6x square plus ax minus b is equal to 0, find the value of a and b. In our previous question, we determined the value of p. We had a single variable p to find, but here we have to find a and b. There we had only one solution, one value of x given. Here x is equal to 2 by 3 and x is equal to minus 1 by 2 are the solutions of the given quadratic equation. Okay, first let's take the case when x is equal to 2 by 3. Equation is 2x square plus ax minus b is equal to 0. When x is equal to 2 by 3, substitute x is equal to 2 by 3. 6 into 2 by 3 whole square plus a into 2 by 3 minus b is equal to 0. Solving, 6 into 2 by 3 square is 4 by 9. 4 by 9 plus 2 by 3 a minus b is equal to 0. We can cancel 6 and 9. 3 2s are 6, 3 3s are 9. That is, in the numerator, you will be having 8. 8 by 3 plus 2a by 3 minus b is equal to 0. Let us take the LCM. Here, denominator is 1. 3 and 1. The LCM will be 3. The numerator 8 plus 2a minus 3b is equal to 0. Okay. Now this 3 can be taken to the opposite side. 0 into 3 you will get 0. That is 8 plus 2a minus 3b is equal to 0. This is our first expression. Okay, let us call this 1. Now, the second part. To get the second part, we have to substitute x is equal to minus 1 by 2 in the given quadratic equation. It is 6x square plus ax minus b is equal to 0. Okay, substituting value of x, 6 into minus 1 by 2 whole square plus a into minus 1 by 2 minus b is equal to 0. That is, minus 1 by 2 square is 1 by 4, not minus 1 by 4, it is 1 by 4. 6 into 1 by 4 plus minus a by 2 minus b is equal to 0. That is 6 by 4, which is equal to 3 by 2. 3 by 2 minus a by 2 minus b is equal to 0. Taking the LCM, 2 in the denominator, 3 minus a minus 2b equal to 0. That is 3 minus a minus 2b is equal to 0 into 2. Taking this denominator to the opposite side, it becomes 0. This is our second expression. Now, on solving this, you will be getting the value of a and b. How to solve this? How to solve this? You have many different methods. You can use a substitution method, elimination method, or cross multiplication method. Now, let's try with the substitution method. From this, let me make an expression for a. 3 minus 2b is equal to a. I can write a is equal to 3 minus 2b. Now, take this value and substitute in first expression. That is 8 plus 2 into, in the place of a, substitute the value of a we have obtained. That is 3 minus 2b. 3 minus 2b minus 3b is equal to 0. Okay. 8 plus 2 into 3 minus 2b minus 3b is equal to 0. 8 plus, removing the brackets, you will be getting 6 minus 4b minus 3b is equal to 0. 8 plus 6, 14. Minus 4b minus 3b, that is minus 7b is equal to 0. 14 is equal to 7b, which means b is equal to 14 by 7, that is equal to 2. We got the value of b, that is 2. Now, in the given expression, to find a, we substitute b is equal to 2. A is equal to 3 minus 2b, which is equal to 3 minus 2 into 2. The value of b is 2. A is equal to 3 minus 2 into 2, 4, which means a is equal to minus 1. And b is equal to 2. This is our final answer. To find the value of a and b, we got a is equal to minus 1 and b is equal to 2 by solving the equations we obtained. From the first part, that is when we substitute x is equal to 2 by 3, and the second part when we substitute x is equal to minus 1 by 2. We obtained two different equations. From these equations, we have used the substitution method to solve this. You can use any method which you like. Clear? Now, let's solve questions from exercise 5A. Here is a first question. Find which of the following equations are quadratic. We have solved a similar example. We have the first expression, that is 3x minus 1 whole square is equal to 5 into x plus 8. This is in the form a minus b whole square. A minus b whole square is equal to a square minus 2ab plus b square. That is 9x square minus 6x plus 1 is equal to, removing the brackets, you get 5x plus 5 into 8, 40. 5 into 8, 40. 9x square minus 6x, taking 5x to the opposite side, it becomes minus 5x plus 1 minus 40 is equal to 0. 9x square minus 6x minus 5x minus 11x plus 1 minus 40 minus 39 is equal to 0. Now, we obtained an expression. This is of the form ax square plus bx plus c is equal to 0. This is the standard form of quadratic equation. Here the value of a is 9, value of b is minus 11 and value of c is minus 39. Therefore, the first expression is a quadratic equation. Got it? Now the second expression. Let's see if this is a quadratic equation. 5x square minus 8x is equal to minus 3 into 7 minus 2x. We'll get 5x square minus 8x is equal to, removing the brackets, minus 3 into 7 minus 21 plus minus 3 into minus 2x is plus 6x. That is 5x square minus 8x. Bringing these terms to the LHS, we'll get minus 6x plus 21 is equal to 0. 5x square minus 8x minus 6x minus 14x plus 21 is equal to 0. We again obtained in the form ax square plus bx plus c is equal to 0. Here a is equal to 5, b is equal to minus 14 and c is equal to 24. This is also a quadratic equation. Clear? Now let's take the third expression. The third expression we have x minus 4 into 3x plus 1 is equal to 3x minus 1 into x plus 2. On solving, we have x into 3x plus 1 minus 4 into 3x plus 1 using the distributive property is equal to 3x into x plus 2 minus 1 into x plus 2. Removing the brackets, we get 3x square plus x minus 12x minus 4 is equal to 3x square plus 6x minus x minus 2. Now, this is equal to 3x square plus x minus 12x minus 11x minus 4 is equal to 3x square plus 6x minus x, that is plus 5x minus 2. Bringing all the terms on RHS to LHS, we get 3x square minus 3x square minus 11x minus 5x minus 4 plus 2 is equal to 0. 3x square minus 3x square can be cancelled. You are having minus 16x minus 2 is equal to 0. What about this expression? Is this quadratic? Not a quadratic equation. Why? This cannot be expressed in the form ax square plus bx plus c is equal to 0 or ax square plus bx is equal to 0 or ax square plus c is equal to 0. We don't have a term containing x square. This is not a quadratic equation. Let's check the fourth expression. X square plus 5x minus 5 is equal to x minus 3 whole square. X square plus 5x minus 5 is equal to x minus 3 whole square. A minus b whole square. A square minus 2ab plus b square. That is x square minus 6x plus 9. Bringing all the terms from RHS to LHS, x square minus x square plus 5x plus 6x minus 5 minus 9 is equal to 0. X square minus x square can be cancelled. From this, you obtain that this is not going to be a quadratic equation because the x square is removed. The term containing x square is removed. The remaining is 11x minus 14 is equal to 0. This is not of the form ax square plus bx plus c is equal to 0. Again, the fourth expression is not a quadratic equation. Now, the fifth expression, 7x cube minus 2x square plus 10 is equal to 2x minus 5 whole square. 7x cube minus 2x square plus 10 is equal to 2x minus 5 whole square is 4x square minus 20x plus 25. Rearranging, 7x cube minus 2x square, taking minus 4x square to the LHS, minus 4x square plus 10 plus 20x minus 25 is equal to 0. 7x cube minus 2x square minus 4x square is minus 6x square. Minus 6x square plus 20x plus 10 minus 25, that is minus 15 is equal to 0. This is our final expression. Is this quadratic? No, because here we have a term containing x cube, the maximum degree of a quadratic equation. The maximum degree of x should be equal to 2. Here the maximum degree is 3, which means the given expression is not a quadratic equation. Clear? Let's take the last one, the sixth one. Sixth expression, x minus 1 whole square plus x plus 2 whole square plus 3 into x plus 1 is equal to 0. Let's check this. By now we have got 2 quadratic equations and 3 equations which are not quadratic. X minus 1 whole square is x square minus 2x plus 1 plus x plus 2 whole square, x square plus 4x plus 4 plus 3 into x plus 1, that is 3x plus 3 is equal to 0. X square plus x square, 2x square minus 2x plus 4x is 2x. 2x plus 3x, 5x plus 5x. Then the constants, plus 1 plus 4 is plus 5 plus 5 plus 3 plus 8 is equal to 0. This is the final expression and this is of the form ax square plus bx plus c is equal to 0. Hence, sixth sub-question is a quadratic equation. We obtained 1, 2 and 6 are quadratic equation. 3, 4 and 5 are not quadratic equations. Clear? Okay. Problem number 2. Question number 2 of exercise 5A. First part, is x is equal to 5 a solution of the equation x square minus 2x minus 15 is equal to 0. And the second part, is x equal to minus 3 a solution of the equation 2x square minus 7x plus 9 is equal to 0. Let's start with the first part. How do you solve this? We have solved many examples. X square minus 2x minus 15 is equal to 0. Given that x is equal to 5, we need to find if x is a solution of the equation. By substituting x is equal to 5 in the given expression, if we get LHS and RHS equal, that is, on solving this, if you get 0, then this is a solution. the value of x given is a solution of the quadratic equation. Let's solve this. Take LHS. LHS we have x square minus 2x minus 15. Substituting x is equal to 5. Equal to 5 square minus 2 into 5 minus 15 is equal to 5 square 25 minus 2 into 5 10 minus 15 is equal to 25 minus 10 15. 15 minus 15 0. LHS is equal to 0. Then what is RHS? RHS is already 0, which means LHS is equal to RHS, and hence x is equal to 5 is a solution. X is equal to 5 is a solution of the given quadratic equation x square minus 2x minus 15 is equal to 0. Now, the second part. The second part, we need to find if x is equal to minus 3 is a solution of the equation 2x square minus 7x plus 9 is equal to 0. Let us substitute x is equal to minus 3. Here, LHS is equal to 2x square minus 7x plus 9. Putting x is equal to minus 3. This is equal to 2 into minus 3 square minus 7 into minus 3 plus 9 is equal to 2 into minus 3 square is 9. 2 into 9 minus 7 into minus 3. That is minus 21. Minus 21, and here we have a negative. We get plus 21 plus 9. This is equal to 18 plus 21 plus 9 is equal to 21 plus 9, 30. 30 plus 18, 48. So, LHS we got a big value, that is 48, and RHS is just 0, which means LHS not equal to RHS, and hence x is equal to minus 3 is not a solution. X is equal to minus 3 is not a solution of the given quadratic equation 2x square minus 7x plus 9 is equal to 0. Clear? We have solved examples, similar examples. So, we can solve this easily. Next problem. Problem number 3, question number 3 of exercise 5A. If root 2 by 3 is a solution of the equation 3x square plus mx plus 2 is equal to 0, find the value of m. Very simple. When we solved the examples, we had a question to find the value of p. Similar question we have here. X is equal to root of 2 by 3, because it is given that if root of 2 by 3 is a solution of the equation, which means x is equal to root of 2 by 3. We will be substituting x is equal to root of 2 by 3 in the given equation. 2x square plus mx plus 2 is equal to 0. When you substitute, you get 3 into root of 2 by 3 whole square plus m into root of 2 by 3 plus 2 is equal to 0. Root 2 by 3 whole square will be equal to 2 by 3. That is 3 into 2 by 3 plus m into root of 2 by 3 plus 2 is equal to 0. Here cancelling 3, you get 2. 2 plus 2, 4. 4 plus m root of 2 by 3 is equal to 0. We can take this 4 to the opposite side. We will get m into root of 2 by 3 is equal to minus 4. Clear? Now we need to find the value of m. That is, take the reciprocal of root of 2 by 3 and multiply in the RHS. That is minus 4 into root 3 by root 2. Root 2 by root 3, the reciprocal is root 3 by root 2. Now we can just rearrange this. That is minus 4. When you multiply root 2 on the numerator and denominator, you will be getting minus 4 into root 3 into root 2 is root 6. Root 2 into root 2. That is, we are removing the roots from the denominator. Just for that purpose, we are multiplying numerator and denominator with root 2. You get 2 here. Final answer, 2 and 4 can be cancelled. Minus 2 root 6. The value of m is equal to minus 2 root 6. Clear? Let's move on to the next problem. Problem number 4. Question number 4 of exercise 5A. 2 by 3 and 1 are the solutions of equations mx square plus nx plus 6 is equal to 0. Find the value of m and n. Similar example we have solved. We found the value of a and b. You remember that? Same steps. Given expression mx square plus nx plus 6 is equal to 0. First, let's substitute the value of x is equal to 2 by 3 because x is equal to 2 by 3 and x is equal to 1 by 3 are the solutions of the given quadratic equation. When you substitute x is equal to 2 by 3, what do you get? M into 2 by 3 square plus n into 2 by 3 plus 6 is equal to 0. That is 4 by 9 m plus 2 by 3 n plus 6 is equal to 0. Taking LCM, we get 9 in the denominator, 4m plus 3 into 3 is 9, 3 into 2 you get 6, 6n plus 6 into 9 that is 54 is equal to 0. 4m plus 6n plus 54 is equal to 0. Now here we can cancel with 2 throughout. You get 2m plus 3n plus 27 is equal to 0. This is our first equation. Okay. Now let's find the second equation. When we substitute x is equal to 1, you get square into m plus 1 into n plus 6 is equal to 0. That is 1 square 1. M plus n plus 6 is equal to 0. This is our second expression. Equation number 2. Equation number 2 implies we can make a value for m. M is equal to minus 6 minus n. We can write like this. Now substitute this value of m in equation 1, that is 2 into. In the place of m, put minus 6 minus n plus 3n plus 27 is equal to 0. Removing the brackets, you get minus 12 minus 2n plus 3n plus 27 is equal to 0. Minus 12 plus 27, you get 15 plus 3n minus 2n is 1n. That is equal to 0, which means n is equal to minus 15. We got the value of n. Now we can easily find the value of m. Substituting in this expression, m is equal to minus 6 minus n, minus of minus 15. Because the value of n we obtained is negative 15. That is minus 6 plus 15 is equal to 9. The value of m is equal to 9 and n is equal to minus 15. Clear? We found the value of m is equal to 9 and n is equal to minus 15. Same steps we have done to find a and b in a previous example. So if you remember that steps, you can easily solve this. Same step of, that is the substitution method we have used here. If you want, you can use the elimination method to solve this problem. Clear, right? Here is our last problem today. We have solved many questions related to quadratic equation. Question number 5 of exercise 5A. If 3 and minus 3 are the solutions of equation ax square plus bx minus 9 is equal to 0, find the values of a and b. Same question, right? Just the expression and the values, that is the solution, values are changing. Let's do this. Ax square plus bx minus 9 is equal to 0. First step, substitute x is equal to 3. When you substitute x is equal to 3, now you are experts in doing this problem. Okay, now 3 square 9, 9a plus 3b minus 9 is equal to 0. Dividing throughout by 3, you get 3a plus b minus 3 is equal to 0. This is our first equation. Okay. When we substitute x is equal to 3 in the given quadratic equation, you get this expression. This equation is our first equation. Now the second, when x is equal to minus 3. When you put x is equal to minus 3, you get minus 3 square a minus 3b minus 9 is equal to 0. Minus 3 whole square is 9. 9a minus 3b minus 9 is equal to 0. Same step, dividing throughout with 3, you get 3a minus b minus 3 is equal to 0. This is our second expression. Now look at 1 and 2. When you compare 1 and 2, you have similar terms. Yes? So let's use the elimination method to find the value of a and b. Okay? The first expression, 3a plus b minus 3 is equal to 0. Now subtract the second from this. Minus 3a minus b minus 3 is equal to 0. What do you get? 3a minus 3a, you get 0. b minus of minus b, that is plus 2b. Minus 3 minus of minus 3, that is plus 3. Minus 3 plus 3 is again 0. This is equal to 0, which means 2b is equal to 0 or b is equal to 0 by 2, which is clear. We got the value of 0. Now, we need to substitute the value of b either in equation 1 or in equation 2. When you substitute this, you will be getting the value of a. Let me take equation 1. Equation 1 implies 3a plus b. b is 0. Minus 3 is equal to 0. 3a minus 3 taken to the opposite side is equal to 3. Which means a is equal to 3 by 3 or a is equal to 1. The value of a is equal to 1 and b is equal to 0. This is our final answer. Concept is clear? Now we know how to find the value of a and b. If it is a and b, p or q or m and n, whatever it is, to find this will be given two solutions. If we need to find two variables, that is a and b here, we are given two solutions. If we need to find only one variable, for example, the question where we determine the value of p, there one solution was given. Depending on the number of solutions, we can find the value of whatever is to be determined. Clear? That's all for today. In today's class, we have discussed the basic ideas about quadratic equation. We studied the standard form and solved many examples. Keep practicing. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.